Alligator clips, very useful, great for gripping onto loose wires or extending wires across an open area. For example, I'm bringing a 5-volt supply and ground from an off-camera power supply right now. I just can't reach. So I'm bringing the power to this point and then clipping onto DuPont. But beware if you're going to be relying on the connectivity of Alligator clips. For example, here's my 5-volt bench solid power supply, 5 volts, and I made a voltage divider out of two 10K resistors. So let's hook it up. This is ground. This is +5. This is just a spare chip. Let's verify we have 5 volts on the breadboard power strip. There we go. So we should have 2.5 volts in the middle of this voltage divider. Perfect. What if, for some reason, I had something else going on up here and this 5-volt power line is not going to reach? Well, let's just add another Alligator clip. See how it goes. So I have this spare one, match the colors so I don't get confused, even though I shouldn't be using yellow for +5. I had to use what I had on hand. So I've got my extension Alligator clip in line with +5 volts. I know the circuit works, so just let me double check. I got 2.5 volts on my voltage divider. 2.43, 2.3. What? What's going on? Okay, what's my main supply? 4.82? What? 4.7, 4.8? Okay, wait. My incoming is 5 volts. All I did is I added this Alligator clip. Okay, 4.77, 4.74, 4.7. What is happening? 5. 4.8 something. So I'd expect maybe, I don't know, 1 or 2 ohms on this Alligator clip. 15K, 16K, 50K. I guess I'll have to do a teardown of an Alligator clip and see what's going on. Okay, I'll pull back the sheath. I don't know how Alligator clips are normally prepared, and I don't know how cheap these are. I think I've had them for a long time. It kind of looks like all they did is crimp the insulation, and then the stranded exposed conductor just sits there, making contact. It would be nice if this were soldered on or something. Even just because over time the wiring's going to oxidize and build up a resistance. Or, you know, this is mechanically going to move around and move out of place, right? But I guess that's just how they're made, so we have to be careful of it. So I'm curious then, how does this one that seems to work, how does that go? It looks like the same thing, except I guess it looks like the insulation crimp is tighter, so maybe it's putting more mechanical force on the exposed conductors and it's making good contact. But eventually, I guess, this is bound to fail as well. And this may be subjective, but this one that's failing, it kind of looks older, darker, dirtier. There could be just different colors of yellow. These aren't the exact same cable, but in person, this looks grimier. It feels less flexible. It's like it's losing its properties. I might have had this for 20 or 30 years for all I know, and this one 2 years. So maybe this one has just reached a point where it needs a touch-up. I can't find my old helping hands clamp to hold this onto, so a big hunk of metal, nice old speaker with something to try to protect the paper fragile cone if I have solder splashes. And since this is a big hunk of metal I have to heat up, I'm going to bring out the big gun, which has an incandescent light, none of this LED stuff. So I'm just going to go for it and blast this with heat, add some solder, and hope I don't melt the insulation back. I'm not using any special technique here. I'm just trying to secure it because I need a quick fix on this so I can use it. And it's already flowing. So I think that's good enough. I still have the insulation hanging on, so between that and the actual now solder joint mechanically helping, this should be okay. It could probably be better, but I just kind of put the solder on the existing lump of wire, so it's shiny enough where it needs to be, but yeah, it looks like a big ugly mess because I was just basically re-tinning a hunk of wire. But it's still holding on, seems good. So I'll put the sheath back on. Do the other side. What I like about using this gun as well, it's got its own built-in stand. Just lay it on its side and it's up off the work surface. So now, checking the resistance of this repaired cable, I've always been told less than 1 ohm is considered a good ground in terms of chassis grounding when designing and building equipment and testing it on the production line. And if I clamp it on to get the best possible connection, I would say 0.2 ohms is a good short. As a point of reference, this other random Alligator clip gives 1 ohm or so. You know, I don't know how old or new it is. I've never had to modify it. So when these things start their lives, they're okay, but they might need a little repair. And if you're going to use them for anything that you think is critical, or if you're getting strange results in a circuit and you're using Alligator clips, you might want to just buzz them out and see if they are part of the problem. Okay, our voltage divider 5 volts and ground through our extension Alligator clip. The main 5 volt supply, 5.00, 4.99, halfway 2.5. Fixed.